Well, class, last week we got to start learning about pandas, and we got to see some of the cool stuff we can do with it. This week, we're going to dig a little deeper, and we're going to do some pandas data frames to do a data analysis really from start to finish, from bringing in the data to observing it, to manipulating it, to structuring it, and trying to find answers to questions. So kind of following that all the way through, we're going to get into a little more depth than what we did previously as we use this new tool. And at the output of this, you would typically be prepared for building out your visualizations, which will be next week. So each one of the topics has the same name this week, just because this one is Data Analysis Start to Finish, Part 1. So first, we're going to go ahead and import the library, like we do every time, just to make sure that we have that available. And now we can bring in our data set as a data frame and assign it to a variable. So this week, we got a really cool data set to work with. It is Kickstarter projects, and someone had gathered all of the information they really could about Kickstarter projects from like 2015 to whenever this data set was created. So if I just bring up the view of it here, I think it'll come up in this view. It's a very large file. You can see that there's several columns here and then data, and there's actually about 370,000 rows here. So it's the kind of thing you could still do in Excel, but or other programs, but it is getting towards that range where it becomes more difficult to utilize those tools for your analysis. If this was, let's say, over 1 million rows, Excel kind of becomes very difficult to do these kinds of things. So then you would need to move into an environment like this or a more powerful tool set. But Python is pretty good for this, and Pandas is pretty good for this. So I'm going to bring in that data set. There we go. So now I've got it available. I have assigned the index column as ID because I know ID is unique in the data set. Okay, now we've got our data. Now let's take just a quick peek at the shape and some of the data in the data frame. Always the best thing to do at first is just get a feel for the data. So I'm going to just kick out the shape of the frame, and then I'm going to look at the first couple of rows just to see what they look like. And as you can see, we've got about 378,000 rows, 14 columns plus the ID column, making 15. And then you can see there's the name of the project, the category of the project, the main category of the project, currency, deadline, goal, launched, pledge, state, backers, country, U.S. pledged, and then it goes on and on. So there's quite a bit here, and we're only going to look at it from one aspect. This is the kind of data set you could spend a lot of time messing around with because there's just so many cool things you could look at. But I'm kind of interested in backers, and generally what I want to know is, do projects with more backers have a tendency to be more successful? So does their state move into success? I would expect, my theory, and it should be probably your theory as well, is that more backers means it's more likely to succeed. But let's actually look at the data to prove that. And that'll be closer to the end. First, we're going to continue looking around a little bit. So let's look at the shape of the backers column. So I'm going to look at the data set backers column, and then I'm going to look at the value count. So one of the cool things you can do with value counts, we didn't do it last week, is you can assign it into bins. So it will create 10 equal range bins to in your output, so you can see what ones fit in each one. So you can see it started at negative 219, just because, and it went up to 131,000. So each of these bins is the same length or same range, but you can see that the backers are heavily skewed in the negative 219 to 221,900 range. I don't think that's a shock, but it is interesting that there is kind of a long tail here. There's a few projects that fall well into the 100,000s for backers. So I'm interested in that too. But this doesn't, other than the fact that this is a very tall along the x-axis and the very long tail, we can look at this a little bit better, I think, if we adjust our bins a little bit. So, as I said, heavily skewed in the low end with a long tail. We can break the data into equally filled buckets, I guess would be the better term for that. So instead of having equal sliced ranges, we can instead do it where we can say, take the data and break the data into however many buckets, and make sure that each bucket is equal in quantity in that bucket. So the ranges of the buckets vary instead of the data falling into specific ones. So here, let me just show you, because I'm not explaining as well as I probably could. Again, I'm going to do the backers. I'm going to do Q cut, and then this tells me how many equal buckets I'm breaking it into. So in this case, you can see that my bucket ranges vary pretty heavily. Here's the bucket range here. So there's a bucket range from essentially 0 to 1. So 1 inclusive, because it's got the bracket at the end, and then 1 backer to 3 backers, 3 backers to 12 backers, 12 backers to 34 backers, 34 backers to 94 backers, and 94 backers to 219,382 backers. So you can see that the bucket ranges are much varied, because so much of the data falls into that first section. So I know the way this essentially works is I can say this bucket has about the same number of backers in it as this bucket, has the same amount as this bucket, et cetera, et cetera. So instead of my data falling into whatever bucket they happen to fall into, I'm forcing the bucket sizes to fit the data. Okay, so there are a lot of projects in there, and they're very small. And I'm not interested in them. I want to, maybe I should be, but I'm not. I want to just look at the ones that have at least gotten 20 backers, because I'm sure a lot of people put out projects that just never get off the ground, which is why you get 1 or 2 backers in the whole thing. So I'm going to get rid of anything that has less than 20 backers. First, I'm going to create a list of the row IDs that need to be removed, so I know which ones to dump from my data frame. So you can see here, I've got a variable called kickstarter, kick rows to delete, from kick all, where kick all backers is less than 20. And then I'm going to print that so you can see it. And then I'm going to convert it to a list, and I'm going to print the first 10 items in the list. I'm printing the shape, so you can see that it is 217,000 items long, or tall, because before I convert it to a list, it's a data series. 217,000 items will be removed, and this is what the list looks like. So these are all IDs that can be utilized when I want to remove them from my data frame. So I'm going to use that list to drop the matching rows from the data frame and assign the results to a new data frame. As I said previously, or last week, when you do major changes to your data frame, it's usually a good idea to just create a new data frame to put it in, so you don't mess up your original frames because you do something wrong. So I'm going to call this one kick, and this should be 20 backers. I made some adjustments here because originally I was cutting it for 50 down, cutting off 50 down. I changed it to 20. So just anywhere you see 50, assume it's 20. I'm not sure why that didn't save, but this is going to be called kick 50 backers. And then I'm going to drop anywhere where the kick all ID equals kick rows to delete. So anywhere where the rows to delete list matches my data set, it will delete it, and then I'm going to print the head and the shape so you can see my new frames size. So here's the, again, first 5 rows. Comment that out and do it again. So you can see that I now have 161,000 rows of my original 370,000 left. Okay, so that's just the beginning part. So we're going to continue now in part 2. I'm going to go ahead and sort my new data frame by backers to see which projects have the most backers. So I've got my kick 50 backers, again, should be kick 20 backers, and I'm sorting by the backers column, and I want it descending, so the largest ones are at top, so the ascending is false, and then in place means that it actually writes it back to my frame. So my frame's actual order will change to my new sort. If I had in place equals false, it wouldn't update the original frame. And then I'm going to print the head. And I can see, if anybody has heard of Exploding Kittens, it's supposedly a really popular card game. I had to look it up. So you can see that that is the most backed one. It had 219,000 backers when it was introduced in 2015. Behind that, Fidget Cube, and behind that, Reading Rainbow back. So that's pretty cool. So all of these things were wildly popular campaigns, and they were all successful, which shouldn't be a surprise with that many backers. Okay. I'm curious what categories of projects or main categories of projects get the most backing. So I'm going to do a group by on main category. So you can see I've got my frame.group by main category. So that means it will group them together on main category. And then I'm going to force it to sum all of the values that it can sum within that new data frame called kick50 group main cat. Okay, so now I've got a summed frame where everything is grouped by main category. Now, when you deal with numbers this big, because we know they're going to be in the 100 millions, Pandas by default will output it in scientific notation, which is great and specific, but it's not pretty. So I'm going to go ahead and override it. You can override the overall Pandas settings when you import it, like you can set what you want for defaults. I'm just going to go ahead and override it on the specific output. So you can see I'm going to print the head of that frame, head 15, but I'm going to do .style.format, a single decimal float, so that I can not do scientific notation. So I can see all the big numbers, and you can see that I've got a whole bunch of big numbers, and I'm just showing those 15. Now, this is not in an order of any real value. You can see that it's actually sorted by the main category. So art, even though it's the first in the list because it's A for art, is not necessarily the one with the most backers or the one with the highest goal or whatever. So not as good as it could be. Nothing really valuable can be done just looking at this in its current state. So let's go ahead and sort it by the goal category, the total goal, and see what the average pledge per backer is. I'm doing two things here, sorry. I'm going to sort it by highest category total goal, and I'm going to go ahead and add a column to this data set that shows the average pledge per backer in that category, so I can see how much people give by category. So a couple of things at once here. First, I'm going to sort by goal. You can see that. It's going to be descending again, and it's going to be in place, so it's going to update the frame. Then I'm going to create a new column in this frame called pledge per backer, and I'm going to assign it to the pledged divided by the backers. So that will give me pledge per backer. And then I'm going to print the head and give it that nice formatting again. So you can see now I've got film and video is the one with the highest goal as a category, which actually kind of surprised me. I thought it was going to be either technology or games. Must be a lot of large projects that ask for a lot of money there. And this new column is here that wasn't here before. So I can see pledge per backer, $96 on average per backer for film and video, $65 for publishing, 107 for fashion, et cetera, et cetera, et cetera. So pretty interesting, some of those numbers. I can also look at the tail if I want to, and I just want to make sure that we don't just have to look at the head, but I can look at the tail here, and you can see that dance is the smallest total goal category. Maybe it's because there are less dance projects created, or it could be any number of things. It does also have about average, it looks like, pledge per backer. Okay, I'd just like to have a look at the biggest categories for what I'm looking at right now as I'm digging into this thing. So I'm going to cut off the stuff that has a lower goal. So I'm going to say my trimmed equals my main category where goal is greater than, I think I did, what is that, 100 million, 10 million, 100 million. So any category that doesn't have a total of 100 million in the goal is going to get cut off when I create this new frame. And I'll go ahead and print it. And you can see now I get, I did tail here for whatever reason, but it doesn't matter because there aren't that many. I could do head 15 and I get the same result because there was only film and video down through fashion, and everything else got cut off in the new frame. So now I'm looking at just the top categories. So just something you can do if you just want to cut off there. Continuing the analysis again. It's really hard to do a decent analysis on the backer counts because they just aren't discrete. So I'm going to create buckets again of backer counts so I can see the data a little bit easier. I created these buckets kind of arbitrarily. I would suggest if you were to do this in a real analysis, maybe you do something like standard deviations or something of that nature that's a little more mathematically valid. I just played with these numbers a little bit until I got some decent buckets. So I've got 0 to 50, 51 to 100, 101 to 200, et cetera, et cetera. This is how I can assign the bucket sizes. You see I do a PD cut there. And the nice thing about this is it's going to create a new column called backer groups in my data set that shows the buckets that the data is in. So I'll print that so you can see it. It's going to go off the screen. That's kind of annoying. There we go. So if you can look over here at the end now I have a backer groups column where you can see that it says, I can look at the backers column here. This one has 219,000. That's in the 10,000 to 10 million group. And so each one of these projects has a bucket associated with the number of backers. So now I have discrete groups of backers, and I can utilize that to do some more analysis. So with my new buckets, I can do some counts. And so here I've got my Kick 50 backers, backer groups, .value counts. And I can see this is the amount that are in each one of my buckets. So, of course, as you go up, the amount in each bucket decreases because the bigger projects are less common. But I can see that I've got all my data bucketized now. So now we can finally have a look at what I wanted to look at originally to see if more backers makes a higher chance of success. So first I'll create a frame, not a from, that is just the columns I'm interested in. So we've done this a couple of times now, previous weeks. So I've got my Kick 50 backers .locate, give me every row, but just give me the backer groups column and the state column. And then I'm going to assign it to a new frame called Kick Success by Backers. And then print it out, which I think you know what that looks like already. It's just essentially an ID column, backers column, backer groups column, right? Because I chose backer groups, and state, which is the state is whether the project or what current state the project's in, whether it's live, failed, successful, etc. So with that data, I can get counts by state by backer group. I think I might have to kick out of this view to get this one to work, but let's try it. So I've got my new frame, Kick Success by Backers. I'm going to group by backer groups, and then I'm going to do state value counts. So it does run off the bottom of the screen, you can kind of see. For each one of the backer groups, I can see the count of state within that backer group. So for 0 to 50, I've got 34,000 of them successful or are in a current state of successful. 21,000 are a current state of failed, 4,100 canceled, live, and suspended. So I can see for each one of these groups the counts of state, which is pretty valuable. It's helping me break what is just a lot of data down into a view that's a little bit easier to see. However, I think we can do a little bit better than this. So it's nice to be able to look at percentages instead of numbers because it just you can see relative to the others how it looks. So very similar again. I'm going to do a group by backers. I'm going to do value counts on state. But I'm going to do normalize equals true, which will make it normalize to 0 to 1. And then I'm going to multiply times 100 to make it look like a percentage. So same thing, same data as before, but now I can see 57% of those are successful, 35 are failed, 6.8 are canceled, et cetera, et cetera. So I can see relative to the other states how each one of these things do. And I can also look at a higher level and say, well, I can look at successful for small backer groups is only 57%. If I get bigger backer groups, it goes up to 74, then 82, then 87, then 92, and on and on. It goes off the bottom of the screen again. But definitely trending upward, which shouldn't shock us, right? Because more backers means it's more likely that the project is to meet its goal and succeed. So the numbers trend upwards as you get into larger backer groups. It's also good to look at the overall success rate to see how each one of those groups is against the average. So I can just do, in this case, just look at state value count and again do the normalization. So I can see overall 72% successful in a successful state, 21% are in a failed, 5% canceled, et cetera, et cetera. Now, the thing we need to remember, this success rate is decent because we cut off everything under 20 backers. So there's a big group here that's not represented. We have to remember that when we take data out of our data sets. Probably this number will be much lower because there's probably 50,000 projects that are 0 backers. So those are obviously going to be failed campaigns. Okay, so data analysis start to finish part 4. No code here. This is just part where, I had kind of showed some data that was in a somewhat summarized format, but I wouldn't step into a meeting with someone to try to explain all that if they weren't a developer or a data scientist themselves. So we need to break that down into something a little bit easier to consume. So we will be dealing with visualization next week, where we can take some of that data. I might use the same data set, I haven't decided yet, to try to visualize it, to make it more consumable and more quickly readable by people that need to look at it. I've also just got a really small snippet in this module explaining what the .npy format is and what pickling is. .npy is a format where you can save your data from your notebook or from a frame or a NumPy array into a format that is very quickly accessible. So much faster than trying to save it off into a database or save it off into a CSV file, something that can very rapidly be accessed. So if you're dealing with, again, millions of data points, and you've got it in this giant array, being able to save it in a .npy format makes it so you can very quickly bring it back and do analysis on it or whatever. So you can keep your information readily and quickly available. Pickling is a serialization where it can serialize your data set. That's not just limited to NumPy and Pandas, but it is used quite a bit in those, where it saves the state of your data as well as the data itself. There's a link there that you can step through a tutorial. It's just you need to be aware of those things if you ever have to deal with a large data set, or if you run across a .npy format file, so you know what that's all about. Okay, so as I said, that's it for this week. We've stepped through an example, essentially analysis start to finish. Again, we just looked at one kind of question of the data. There was a lot we could have asked about that data. It's a pretty rich data set, and we could have looked at a lot of different things about it. And I may look at some other things with the visualization next week, so we can look at it from some different angles. I think we can definitely make it so we get a better idea of what's going on in that data and be able to share it with other people. So something to look forward to next week. Maybe you want to play with that data set yourself between now and then, see what kind of information you can find. That's totally up to you.